5.2, natural log integration. So today we're going to look at integrating with our answers having natural log in them. Okay, so remember the integral of 1 over u du, or du over u, is equal to the natural log of, it should say u, plus c. All right, that's that indefinite integral. And then, so our log rule for integration is the integral of 1 over x dx is equal to the natural log of x plus c, or if we're using u substitutions, same concept there. Okay, so some methods that we're going to look at is u substitutions, all right? Sometimes we'll have to use division, sometimes long division. You can use the change of variables, and then don't forget about those trigonometry rules, all right? All those trig functions. So let's dive right into our first example here, okay, where we want to integrate 8x cubed plus 6 over x to the 4 plus 3x. Go ahead, try this on your own. Hint, you'll need a u substitution. Okay, so I let u be x to the 4th plus 3x, but when we when we take the derivative, we get 4x cubed plus 3 dx. But I need it to be 8x cubed plus 6 dx. So all I need to do is then double du to get what I need here to make that nice substitution. So as we continue on, we're just left with 2 times the integral of u to the negative 1, because it's like saying 1 over u, du. And now we can integrate this. U to the negative 1 is ln of the absolute value of u. And now we just have to make our substitution back, so it's in terms of x. Don't forget about that plus c, and we have our answer, 2 times the natural log of the absolute value of x to the 4th plus 3x plus c. Example 2, we have this big function all over one single term. So what's the best approach here? Hopefully you recognize, let's break it up and divide each term in the numerator by x squared. All right, so we're going to break it up, x cubed over x squared minus 6x squared over x squared plus 3x over x squared plus 5 over x squared. When we do that, we make it a little easier on ourselves. Okay, so now we can integrate each piece. So we're really just left with the integral of x minus 6 plus 3 over x plus 5 over x squared dx. So now integrating, the only one that's kind of drawing a red flag to me is this one right here, right? So 3 over x to the first power, or 3x to the negative 1. So that's telling us natural log with that guy. Well, as we continue on, integrating x, we get x squared over 2. Integrating negative 6, we get negative 6x. Integrating 3 over x, we get 3 times the natural log of the absolute value of x. And then integrating 5 over x squared, we get negative 5 over x. And we can't forget about that plus c. Example 3 is now similar to example 2, only this time we're dividing by binomial. So we can't just break it up term by term. What we're going to have to do, if you can think about it and possibly guess, we need long division. All right, so we're going to do some long division here. I'll walk us through it just to get a quick refresher of this long division. So remember, when we're using long division, I want to know, okay, what can I multiply x by so I get x squared? Well, that's x. So I multiply x by x and by negative 1. So we get x squared minus x in the denominator, and then we just have to change those signs because we add these together. And when we add those together, the x squareds cancel, and we're left with negative 4x. We bring that plus 3 on down. Now I have to ask myself, okay, I need x to be negative 4x. So what do we need to multiply by? We need to multiply by negative 4. So negative 4 times x is where we get negative 4x. Negative 4 times negative 1, we get plus 4. And now again, I'm just going to change these signs underneath because we're adding those two quantities together. And when we do, we have 3 minus or plus a negative 4, which leaves us with negative 1. And this is our remainder. So what is our ultimate answer? We have x minus 4 plus negative 1 over what we were dividing by in the first place, x minus 1. So now we can go ahead and rewrite our integral as the integral of x minus 4 minus 1 over x minus 1 dx. I want you to pause and try to integrate this on your own. Check back when you're done. Hopefully you got what I got. Integrating x, we get x squared over 2. Integrating negative 4, we get negative 4x. Integrating negative 1 over x minus 1, you could think about a u substitution here, but what it would do is it's going to just lend you back to the natural log of the absolute value of x minus 1 plus c. So let's just kind of walk through. If we did that u substitution here, we would let u be x minus 1, then du is simply going to be 1 dx. So we've really got the integral of 1 over u du. And so when we integrate that, we would get ln of the absolute value of u plus c, and then we substitute back, and that's where we get the natural log of the absolute value of x minus 1. Finally, this last example here, we need to integrate 1 over 1 plus the square root of 5x. Okay, hopefully we realize we need to use substitution. So let's let u be 1 over the square root of 5x. So if that's the case, then du is going to be taking the derivative 1/2 of 5x to the negative 1/2, don't forget about that chain rule, times 5 dx. Okay, so if we get dx by itself, because that's what we need over here, we only have 1 times dx. So we need dx all by itself. And if we do that, we have 2/5 times the square root of 5x du equals dx. But this lends to a problem because we need this in terms of u, not x. So what we need to do is we need to make a substitution. So we know that u is equal to 1 plus the square root of 5x. So what we need to do is we need to solve for what the square root of 5x is equal to. So it's in terms of u. So all we need to do is take that u value, subtract 1, and now we have the square root of 5x in terms of u. So if we substitute back into that dx equation, we now have 2/5 times u minus 1 du is equal to dx. So now we can make that substitution into our integral, and it's going to look something like this. So our dx is this value right here, 2/5 times u minus 1 du all over u. So just kind of cleaning this up, bringing our 2/5 out in front. And now since we're just dividing by one quantity u, I can take u divided by u, and that's where 1 is, minus 1 over u, and that's where we get this portion here. Now it should be a lot easier to integrate, so we can go forward. So we still have that 2/5. Integrating 1, we get u, minus the integration of 1 over u is the natural log of the absolute value of u. Don't forget that plus c. And now it's just a matter of substituting back in for u, and we get our final answer. 2/5 times the quantity of 1 plus root 5. Oh, sorry, root 5x, right? Root 5x minus the natural log of 1 plus the square root of 5x plus c. If you have questions, let me know. We'll see each other in class.